All right, guys, welcome to day 2 of 2.2.1. So today, we're going to try and expand on what we did the last time. So last time, we found all of those different rules for moving stuff up and down, left and right, doing vertical expansions and contractions, and even doing vertical flips. So now we're going to say, hey, how can we generalize those particular rules? So we normally would do this on a big old poster for each class, but we're just going to kind of generalize these. What are the rules as we would kind of try and show them? I'm actually going to do this on paper just so you can kind of see me write it out, because it's just a little bit easier than trying to just verbally explain it exclusively. So pull up my document camera. Okay. All right. So if I want to move or do a shift left or right. Okay. To do this, I have to add on the inside. So if I have f of x, what I actually do is f of x minus h. Okay, so I'm adding or subtracting on the inside. And what that looks like is if I had x to the third, that would be x minus h in parentheses to the third. So whatever the x was, I just subtract an h where it is, right? And that causes my left-right shifts, okay? And then if I want a vertical shift, so shift up or down, we're going to take our base function, and we're just going to add to the outside. Right? So an example of that, if I had square root of x, I'll do square root of x plus 5, right? That's going to shift it up 5 higher, right? Or just to be consistent, I'll write that as k. Right? Whatever k is, I move up k or down k if k is negative, right? That's how I get those shifts, because I'm on the outside of the actual function. So it's still the base function, I just tack it on to the outside of it. Whereas here, remember, I go inside, attached to that x, as close to the x as I can possibly get it. Then what if I want a vertical stretch? Or a contraction? So on that, if I have f of x, all we did was we just multiplied in front of it. So if I did a times f of x, right? So if I were to have say the cubed root of x, if I do 5 times the cubed root of x, sorry again, a times the cubed root of x, I'm trying to not do specific examples here. Anything that I multiply on the outside of it, that causes a stretch or a contraction. It'll be a stretch if it's bigger than 1. It'll be a reduction or a contraction if it's less than 1, meaning a number between 0 and 1, not negatives, right? So that's how I get those. And the last rule, which we kind of covered, is if I can do a vertical flip. Right? And that is if I take my base function and throw a negative in front of it. Right? So if I had, say, the absolute value of x, I could have the negative absolute value of x. Will be that exact same graph, but flipped over. So those are the 4 things we know right now. Right? So I should be able to give you any function, and you should be able to write me what that equation looks like. Or consequently, the other way, I should be able to give you an equation and you tell me exactly what is going to happen to it. So I want you to write me a cubic function, which is x to the third power, in case you don't know that term. And I want it to go right 5, down 3, flipped vertically, and vertically stretched by 2. So write me an equation that meets those criteria. Pause the video, go. All right, So I know it's a cubic, so I'm going to have x to the third, but to move it to the right 5, I want that x to be minus by 5. So x minus 5 to the third. Then if I want to go down 3, I need a negative 3 on the outside here to move it all down. And then to stretch it vertically by 2, I want a 2 out front. And to flip it, I throw that negative in front. And then I get y is equal to, and there is my E equation that meets those criteria. It should get to the point where it's that quick and that easy, right? Where you can just look and say, well, this goes there, to get that, I do that, to get that, I do that, and to get that, I do that, done, right? Now let's try it the other way. What if I give you 1/4 times the square root of x plus 1 plus 7 on the outside, okay? So I can say, hey, well, what does this graph look like? Well, it's a square root function, but how is it altered? Go and pause and write and tell me how this gets shifted. Go. Okay, so now that we're back, what's going to happen? This caused it to be vertically compressed. And you can say compressed, you can say contracted, you can say reduced. Just use wordage that makes sense to you by 1/4. This is going to move it to the left 1. And this is going to move it up 7. And there we go. So if I wanted to actually go and graph that, I could sketch a graph. So here's where it normally would start. So I'm going to go left 1, up 7. It's going to start there, but now it's going to be compressed by 1/4, so it's going to be, as opposed to more like that, it'll be a lot flatter like that. So I can get a decent sketch just off of that. Is my sketch perfect? No, but it gives me all the important parts just from looking at the equation, and that's where I want you to be right now. All right, so closure for today, we normally would go and look at everyone else's. I kind of spend a little bit more time doing that as our closure, so we're going to call that good. So here is day 2. We're doing 88 through 94, and I will talk to you guys next time.